Hello everyone, welcome to today's mathematics class. In today's maths class, we are going to be solving this question on logarithm. And the question says log 8 to base x minus log 16 to base x squared equal to 1. Find x. We know that logarithm is very easy and simple. Alright, when we have common base, so when the bases are the same, then the logarithm, the question becomes very easy to solve. So in this case, we are having a complication here. Why? Because the base here, look at the degree here, is 2, and here we're having 1. So it means that automatically the bases are not the same. So we are going to carry out somewhat algebraic manipulation before we can be able to solve this question. Okay, now, how do we solve this question? We must first of all change this base to the same base. We need to make everything like in the law of logarithm. If I have log x to base a minus log, let's say same x to, okay, let me say log y to base a. So in this case now, the base must be the same. So here is minus, it means at the end of the day you're going to have log x over y, that is, you have a common base, right? It can be equated to anything to solve. But in this case now, we cannot apply this to this here because of what? The bases are not the same. So now we are going to look at formula which we have is called change of base. That's what we call change of base. How do we do that? We are going to change this base to base x. Now, remember this formula. If I have something like this, I have log, let's say log x to base a, okay? And I want to change this base, this a to base b. Alright, I want to change this a to b. How do I do that? I'm going to take the log of this x here, which is the number. It will become the log of x to base b, because this new base. Then all over this former base, that will be the log of the former base a to what? To the new base. So this whole of this will replace here in our solving. So that is what is called a change of base. So now let us look at here. We want to change this x square now to this base here. So which means I'm going to bring this down, have log 8 to base x, then minus. Now let us apply this now. Since we said that the new base, we take the number to what? To the new base, become log 16 to base x. Now this is our x, we want to change it to base x. Then all over. Since also the base, the former base now, you take the log of it to the new base. So which now what? Log, the former base is here is what? X squared, all over what? The new base is what? X. Good. Now we are moving. So in this case now, we are going to take this down. We're going to have log 8 to base x, then minus. Now let me show you one thing in log. If I have log x raised to power 2 or x raised to power n, log x raised to power n to base a. So the power, we call it what? The power log. It will come back and multiply the log. It will now give us equal to n log 16. Okay, n log x rather to base what? N. N log, so whatever power it is, we multiply the logarithm. So now let us also express this 16. We know that 16, let us take it to the lowest. Let's break this down also. We can also break this down as well. 16 is sitting as, let's take it to the power of 2. So we can have 16 to be equal to 2 raised to the power 4. Now we also have here 8 here, log 8. 8 can also be seen as what? 2 raised to the power 3. So let us break it down that way. Okay. So let me replace this 8 here to what? Let me represent it to what? Represent it by what? 2 raised to the power 3, which now have what? 2 raised to the power 3. Then here we are having log 2 raised to the power 4 to base x. Okay. All over. Then we're having log s squared to base x. Okay, now let's go and apply this law now. This power law, see that? So it means that with the power we have to come and multiply the logarithm. the same way here. So which means 3 will multiply the log of 2 to base x. Well, 3 log 2 now to the base of x. Then here we're having 4. We have to multiply, become minus 4 multiplying the log of 2 to base x. Then all over this same 2 will multiply here, become 2 multiply log of what? X to base x. So now let us go further. Yeah, let's clean up this all of this place here. Yeah, bring this down. We're having 3 log 2 to base x, then minus 4 log 2 to base what? X. All over. If you notice something here, we're having 2 here, and here, log of any number to that same number, to the base of that same number. Let's say, for example, log a to base a is equal to 1. So in logarithm, when we have the log of a number to that same, to the base of that same number, so it's equal to 1. So meaning automatically we're having here, these are 2 here, we're having 2 log x to base x. So now this will become 1. Alright. So if this becomes 1, this becomes 1. Okay. So here we're having 3 log. Remember, there is an equation here equal to 1. So don't forget, we have equal to 1. So this is equal to 1, equal to 1. Okay. So 3 log 2 to base x, then minus 4 log 2 to base x. Then this becomes 2 multiplying 1. Sitting as 2 equal to what? 1. Equal to 1. So now this here can cancel this here. This gives us 2. Can cancel that. So we now have 3 log 2 to base x minus 2 log 2 to base x equal to 1. So something is common here. You can see that we're having log 2 to base x, we're having log 2 to base x here. Now let us consider the coefficient. Look at what is multiplying there. 3 multiplying here. Welcome. 3 multiplying here and 2 is multiplying here. Why can't I just subtract? This is written as saying 3 minus 2. So which means I'm going to have 1 of it left. Meaning I'm going to have log 2 to base s equal to 1. So I can use algebraic substitution. But let me just solve it with this now. So at the end of the day, we have 2 log 2 to base x. This is what is going to be raised to this, which means x raised to the power 1 equal to what? 2. So x raised to the power 1 is written as what? X. So x equal to what? 2. So that is your answer. So now let us check if our solution is valid, if our solution is correct. So if it's correct, it means we are going to plug in 2 into the expression. So let us check if we are right. We are having log 8 to base 2, okay, minus log 16 to base 2 raised to power 2. That is what? 2 raised to power 2. Now let us check at the end of the day if everything gives us 1, and it means our solution is correct. So log 8 to base 2 minus, this is what? Log 16. Then there is a law of logarithm. If the base is raised to any power, it means we are going to take 1 all over that power multiplying this. So which means we are going to take this 1 over 2, 1 over 2 log 16 to base 2. Okay, now, so this 1 over 2, according to another law of logarithm, this we have to 16, we have to be raised to this for half, which means we have log 8 to base 2 minus log 16 raised to the power 1 over 2 to base 2. Right. So now let us simplify further. Then anything raised to the power half is what? Square root. It means I'm going to have square root of 16, which is what? 4. Then log 8 to base 2 minus log 4 to base what? 2. Good. So let us apply the law of logarithm. Since this one is negative here, it means we are going to divide this one by this. Then take the common base, which is what? Log 8 over 2. Okay, this is 4. Log 8 over 4 to base 2. So 4 cancel here, 1, 4 cancel here, that's 2. So at the end of the day, we're going to have log 2 to base 2. So log of any number to that same base is equal to what? 1. So it means our solution is valid. So if you find this mathematics class very interesting, do not hesitate to share this post across various platforms. There is somebody who needs this particular knowledge. As you do so, God will bless you. Also do well to subscribe to our YouTube channel, Physics and Mathematics Lovers. Bye.